Hello everyone. In this lab, we'll go ahead and walk through with the Neutron service installation. So, like if you recall, like our NOVA networking, Neutron manages software-defined networking for your OpenStack installation. However, unlike your NOVA networking, you can configure a Neutron for advanced like virtual network topologies, such as per tenant private networks and many more things. Neutron sets up at least one external network. So the this network, unlike the other networking, is not only a virtual defined network, instead it represents the view into a slice of the network that is accessible outside of the even your OpenStack installation. For our demo, we will be using the Open vSwitch plugin. Open vSwitch plugin is one of the most popular core plugins, and and it's something before after Linux Bridge. It's pretty popular now. Before that, we were using like the Linux bridges. Open vSwitch configuration consists of bridges and ports. Basically, you will go ahead and create multiple bridges, and then you're going to attach some of the ports. With Open vSwitch, you can use two different technologies to create the virtual networks, basically GRE or the VLANs. To use the GRE with Open vSwitch, Neutron Network creates a GRE tunnel. These tunnels are ports on bridges and enables bridges on different systems to act where they were like a single bridge. So we will go ahead and start doing the installation on the AIO node, and I'll walk you through with the Neutron installation. It's pretty easy, straightforward, but it can get complicated if you don't understand some of the networking pieces. So we have already sourced the file, but let's go ahead and source our credentials. So I have sourced my credentials, and let's go ahead and start doing the installation. So on this AIU we will be installing the our core things, which is Neuron server and the ML2 plugin, and then we'll go ahead and install the DHCP agent, so we can hand off the DHCPs. We'll go ahead and install our Open vSwitch agent, Open vSwitch, and our layer 3 agent plugins. And once that is done, we will, as usual, will go ahead and create a database for our Neutron, and then I'll walk you through the rest of the configuration files. So let's go ahead and start doing the installation for our Neutron project. So you can see this is what I installed. We went ahead and installed the Neuron server and the ML2 plugin, and then I went ahead and installed the, oh, looks like I repeated Neuron plugin twice. You can ignore that, sorry. Then we installed the DHCP plugin, Open vSwitch, and the Neutron agent. Once that's done, now let's go ahead and proceed for our database creation. So we have done with the creation of a database. As usual, we'll go ahead and create a user by name Neutron. We'll assign the role. Then we'll go ahead and proceed. We'll go ahead and create our services and then the service endpoints. And let's go ahead and create the service endpoint as usual. And here the port will be 9696. Okay, so we have created user, added the role, created service, create the endpoints. Now, uh, we are installing the Neutron on our AIO. So we need to do a couple of things here. We'll go ahead and enable the packet forwarding and we'll disable packet destination filtering so that our network node, which is the AIO node or the controller node, can coordinate traffic for the VMs. And I'm sure you're familiar with Linux, so we'll go ahead and add the our etc sitcdl.conf file, and let's go ahead and make a few changes. So default RP filter, let's change them to 0. We don't want them to be enabled. And let's go ahead and enable IP forwarding to be 1, and let's go ahead and save the file. And let's apply the changes. So serial-p, and you would get to see we changed these three options basically. Now, time to configure the Neutron services. Again, the Neutron services are under etc Neutron directory. So we can go to etc Neutron, and you can see you got plenty of different files: API, paste, DHCP, firewall as service, L3 agent, metadata, neutron.conf, policy.json, root wrappers, and VPN. So let's go ahead and start editing our neutron.conf. So under neutron.conf, let's go ahead and define the plugin that we plan to use. So we will be using the core plugin as the ML2. So let's see if we have anything already defined on the core plugin. So I just want to use the core plugin as the ML2. So let's just keep the core plugin being ML2, and let's take out everything else. Good. Now let's look for the service plugins. So we don't have any service plugins, so let's go ahead and define our service plugins. And we just want to use RAR right now. We don't want anything else. I'm just saving the file. Let's look for the authentication strategy. And let's uncomment this line. We want to make use of the keystone. And let's allow something allow overlapping IPs. So that way we can have the same IP ranges across our different tenants. So I'm just changing this to allow overlapping IPs being true. Let's find out our RPC backend. Let's go ahead and uncomment this line RPC backend Neutron OpenStack RPC combo. Okay, let's go ahead and find out our rabbit host and let's specify some of those details. So here you can see we got the rabbit host, change it from the local host to our AIO hostname or the IP address. If you recall, our rabbit pass is not gas, so we need to change that. We just made the change. And now let's go ahead and update our keystone auth path. So we'll go ahead and add the URI, which is nothing but HTTP AIO and the port number 5000. We'll change the auth host to keep the services, and the tenant is going to be here again. Service, the admin, user is Neutron, and the password we gave as pass. So let's keep that, save the changes. And if you recall that we need to update the database section too. So we can just simply go ahead and comment this line, and let's go ahead and another line that says connection is equals to MySQL and specify the MySQL details. And as a best practice, I would go ahead and simply make sure that this file doesn't exist. And okay, very good. Now let's go ahead and find out a few more details. We go ahead and do here keystone tenant get service, and you would get to see your service tenant. Let's make a note of this ID because we will be needing this ID. Let's go ahead and change our neutron.conf. And this file, there are a couple of things. We want to verify. A lot of things are already here commented, so either we can do a uncomment those lines, or we can go ahead and, so let me find out port underscore status. So this is basically Neutron and Nova interaction, this section. So I'm going to go ahead and okay, let me just uncomment these lines. So we are saying notify Nova on port status change. So you can say send notification to Nova when port status is active, and we are changing that to true. Same thing we'll go ahead and do for the data changes. We're changing that to true. It's asking us for the Nova URL. So let's go ahead and update that too. Nova username. Let's go ahead and give a username of Nova, and we just copied the tenant ID Let's go ahead and paste that over here. Forget. And let's go ahead and specify the password as pass. And let's go ahead and specify the auth URL, which is again http colon 35357/v2 dot 0. So we made few changes. These are the changes allow communication between the network and Nova. So we can see we are sending the notification to Nova whenever a few things are changing. So let's go ahead and save the changes. We have made the changes to the file. Now, to perform DHCP on our software-defined networks, basically networking supports several different plugins. And for the lab, the default one is a DNS mask. So we'll go ahead and use that one. So let's go ahead and edit the file. We're already in the direct. So we'll go ahead and use the DHCP agent. And if you see, pretty much all the lines are commented in this file. So let's go ahead and select the interface drivers. So if you see, here's the line. So for the interface drivers, we are using Neutron agent, Linux interface, and we will be using, let me just comment this line again, and here's the one. So you can see example of interface driver option for OVS based plugins, and we are using this one. So Neutron agent, Linux interface, OVS interface drivers. Now we need to enable the DHCP drivers, and as we discussed, we will be using the DNS mask. So you can see the agent can use DHCP drivers. DNS mask is the simplest and requires no additional setup of DHCP server. So we are using DNS mask as this one. And use namespace. If you recall from Neutron, we did enable allow overlapping IPS. So what it says, allow overlapping must have kernel build this IP route. So we are enabling that support into our DHCP. That's all pretty much. So let's go ahead and save the changes. So we just enable the interface drivers, which are our OVS DHCP driver. We are using DNS mask, and we have enabled namespace. Let's go ahead and save this file, and let's go ahead and configure our L3 agents. So with the L3 agents, we will be again using the OVS. So I'll go ahead and uncomment interface drivers, being OVS interface drivers. We'll go ahead and use the overlapping IP again, namespace equals to true, and pretty much that's all we need to do in the layer 3 agent, nothing else. So let's go ahead and save this file. Now the big and the important file that we need to configure is our ML2 file, which is under the plugins folder. So if you do a ls on the plugin, you will see ML2 directory, and under that you will see a couple of files. So if you got a Cisco switch like Nexus 5000, 7000, if you want to configure, you want to use that one, and some different vendors too if you need to. We will be interested in the ml2conf.ini file, so we'll go ahead and edit this file. So plugins ml2 .ini file. And if you recall, we will be using the GRE over here, so I can go ahead and add the driver types as GRE. So let me just go ahead and type that, and I'm just going to do a copy paste and take the extra stuffs out. So our driver types are GRE, and similarly the tenant networks also going to support GRE. So let's go ahead and copy and use that one. I'm just trying to avoid some typo. Okay, so that part is done, and the mechanism driver, in our case we are using the OpenV switch. So let's go ahead and use that one. So that's all pretty much. And save those changes. Now we just define the GRE. We're going to use the GRE tunnel. Let's define the a range for our GRE tunnels. So pretty much done. Okay, we have just defined the range. And let's enable the security groups. So there are nothing over here. So let's go ahead and add some of the things over here. So instead of type, I'm just going to copy paste from some of my notes. So I will, and you can see that we have saved the changes. So let me just show you one more thing. I have configured ETH1, and if you recall, the ETH1 will be the IP that we will be using for our tunnel communication or for our GRE between the our controller or the AIU and between the compute. So I will be assigning this IP address, so which is 10.165.172. Let me just go ahead and copy. And let's go back to our plugins files, and there is no section for the OVS, so we'll go ahead and add a section for the OVS, and we'll go ahead and define some of the properties. So we are saying the local IP will be the IP, this will be the IP that we'll be using. Tunnel type we'll be using the GRE, and we will say we are enabling the tunneling. So enable tunneling equals to true. Let's go ahead and save this file once that is done. Now let's go ahead and edit our metadata file. So we'll go back to the VI metadata.agent, and if you see there are a few things already defined, so let's go ahead and edit them. Instead of the local host, we'll go ahead and specify our. And if you recall, the region one is the default one, so we're not going to go ahead and change that one. We'll change this to our tenant, so we are using service as our tenant. And our user is Neutron, and the password is pass that have been assigned. And the NOAA metadata IP address used by the NOAA metadata server. So in this case, this is my AIU node. I'm not changing the port, but I'm going to use a shared secret of pass. And if you see what would that mean, when proxying metadata request, Neutron assigns the instance ID header with a shared secret to prevent spoofing. You may select any. So it's kind of think it. NOAA uses a different key, which is Neutron underscore metadata underscore shared underscore secret. Now that piece is done, and if you recall that our AIO is also running the NOAA that we installed, so let's go ahead and update the same metadata secret on that one too. So we'll go to the NOAA and we'll do a NOAA.conf, and under NOAA.conf we'll go ahead and add a couple of stuffs over here. So let me go ahead and add. I'm just going to avoid some typos. I'm going to do a little copy paste from my notes. So we are using Neutron metadata proxy. We have enabled that one, and the shared secret we just defined over there is pass. Now let's go ahead and configure some of the other things. We need to tell our NOAA that where is our Neutron, and what kind of strategy we are using, the URL for the admin URL, what kind of interface drivers we are using, and any security groups or some of that things. So let me go ahead and configure that for you. Let me go ahead and save this file, and then I'll explain you all these things so you can see. We're telling wherever is the URL for the our Neutron, the auth strategy, our tenant username and password, URL, interface drivers. We are using OBS and firewall driver, Nova, which is going to be the IP tables, and we are using a default security graph by name Neutron. So let's go ahead and save this file. And if you see we got an interface by name BR int automatically got created. If now we will go ahead and add that one. You can see it says OBS system, and we got overflow bridge already on the system. So let's go ahead and restart a bunch of services, and so we'll go ahead and restart the Neutron services first, and then open vSwitch, and followed by some of the Nova, and then again some of the Neutron services. So we'll go ahead and start them, which is Nova API, and restarting that one. Next one will be scheduler. Okay, we'll go ahead and restart conductor. Neutron plugin, open switch agent, restart Neutron layer 3 agent, restart service Neutron DHCP agent, restart Neutron data agent, restart, and service open switch restart. And if you recall, and if you see ifconfig ETH2, we had configured the ETH with the manual, so we don't have any IPs or anything on this interface so far. So we will be creating a bridge, and we will be adding the ETH2 as a pod on that bridge. So let's go ahead and create a bridge first. We'll use the command vscal add bridge and give a bridge name. So in this case, we are using BREX. That represents our external interface, so we'll go ahead and use BREX. And on this bridge, let's go ahead and add a port. So we'll bridge name, and we are assigning E2 as a port on this bridge. So if you do here, it's 2, and now you can do a BREX also. So we got created a new interface by BREX. Now let's go ahead and restart a couple of more services again once we are done with this. Services, no, start. We have restarted pretty much all the services now. Let's go ahead and verify that if everything looks good. All our servers up or not. Okay. So it looks like all the services are happy. You can see we have L3 agent running, Metadata proxy running, Open vSwitch agent running, and DHCP agent, and you can see their states. And it does say the admin state being up, and all services looks good. And again, if you want to look for any of the logs, you can go to the var log and the Neutron folder, and pretty much you can have a look and see what's is happening with some of the other things. Okay, so we have the logs, and we confirm that none of the servers went down and all servers are still up. Okay, everything looks good. Let's go ahead and create a tenant network. And to do that, we'll use the Neutron again Python client, and you can do --help if you want to see what are the different options available. So there are plenty of options to do so many things. So we'll use the Neutron and we'll say net hyphen create. Let's give it a name. We're calling it a private net. So you can see the network type is GRE, physical segmentation. Segmentation ID is 1. And this is the tenant ID, which is nothing but our server says. Now let's go ahead and create a subnet for this tenant network we just created. So we'll use the command neutron subnet hyphen create, and let's go ahead and give it our network name, which was private net, and give it a name private subnet, and let's define our subnet as 10.10.10.0/24. Okay, so you can see that we have created the nested. We can do Neuron net list to see your networks list, and you can get to see, okay, with this network you have this subnet associated. Very good. So that covers the installation of the Neutron Neuron server on our AIU node. In the next demo or in the next lab, I will show you how to add additional compute node to your existing AIO. In our case, if you recall that we had a 2-node setup. One is AIO, which is running everything, as well as for the added capacity, we will be adding the compute node. I will see you in the next lab. Thank you.